Off our desk, except the blank piece of paper. Let's write SPC 1.4, Earth's movement data. We're taking 2 sets of notes today. The first thing that we're going to write is rotation versus revolution. So we're writing on a blank piece of paper, SPC 1.4, Earth's movement data, rotation versus revolution. Rotation versus revolution. Rotation is when one object spins on its axis. Please write that down. Feel free to zoom in if you don't have to do the extreme close-up, but feel free to zoom in on that though. Okay? Like this. See this finger right here? See, that's actually pretty good too. Rotation versus revolution is when one object spins on its axis. Okay? Now, let's draw a circle. Let's draw its invisible axis with a dotted line. And then draw a solid line perpendicular to that. Now, what we just drew was the Earth. The Earth is an example of an object that spins on its axis. Rotation, rotates on its axis. So we can label this Earth. We can label the dotted line axis. Then, what can we label the solid line?
Other axis.
Not quite.
Y-axis, x-axis, equator.
Equator. Now, the Earth is split from top and bottom half. These are called the what and the whats. Close. Northern hemisphere. And the southern hemisphere. Please label these the first couple times. Then in the future we can start abbreviating them. Do you need something to write with? Do you need something to write with? Yeah. There's a pencil sharpener over there between stations 11 and 12. It's a new pencil sharpener, so be delicate with it. My last one was broken because someone put a Sharpie in it. We won't have to do that again. Sir, can you sit at this desk so people behind you can see? Sir. Maybe. We'll see if we can get there. Thank you. You can sit in the front right over there so you have a great view. Okay, people. The Earth is on a tilt. It's on an axis. There's a degree angle. That is 23.5 degrees. That's a 23.5 degree tilt. Now, some scientists believe it's all part of the show. Some people believe that a very long time ago, something the size of Mars hit the Earth, making it orbit, making it rotate on its axis. And the spare junk kind of flew out into space while the Earth was still cooling from its formation and created the moon. It's called the collision theory. I don't think we'll talk too much about that, but it could be a bonus question. So we have rotation We have the Earth rotating on its axis. Next, we have revolution. Revolution is when one object orbits another. Revolution is when one object orbits another.
If like the Earth stopped like moving on its axis, would like half of the years just be in darkness like the rest of the year?
That is correct.
So before like the collision theory happened, it was like one time that Earth was moving.
We have no evidence to tell us what was happening before the collision theory. Maybe it was orbiting. Maybe it was rotating the opposite way. We don't know. It's good thinking. Okay, so let's go to revolution. Revolution is when one object orbits another. So in this example, Subhan, I'm filming right now, so I want the audio to be a little bit quieter in the background. So I need you to sit down. I need you to copy the notes. Do you have your piece of paper? Show me a piece of paper. There's a blank one right there in the corner of the desk. You can use that. Please draw the sun, and then we can draw the Earth, like over here. And its orbit is going to be an ellipse, aka an oval. I'm a pro. Compared to the sun, it's actually much smaller than that.
You know, like
Just,
billions of Earth
yeah. Which is kind of amazing because the Earth is so big, but to us it's big, but to the sun it's not. Yeah. So what we have here is the Earth revolving around the sun. So let's collect some data off to the side. One Earth rotation equals, how long does it take? Raise your hand if you think you know the answer. How long does it take for the Earth to rotate once on its axis?
1 day, 24 hours.
Raise your hand if you think you know the answer. Yeah? Not quite. One rotation. 24 hours. Let's write one Earth revolution equals, how long does it take the Earth to revolve around the sun once? Vias' hand was up first. 365 days. Yeah, because you know this orbit around the sun doesn't exactly take 365 days. And 365 days isn't exactly 365 days because one day, 24 hours, isn't always exactly 24 hours. Well, we have to factor in daylight savings time. We have to factor in leap year, right? So since it's not exactly 24 or 365 days, we end up every year with a remainder. So it's not exactly 24. 24 and a little bit extra. So after so many years, all this extra adds up. What we have to do is we have to take back a day, and that's a leap year. Yeah. Fun fact, the Mayan calendar did not need a leap year. It was perfect. No. I don't know. Their math was better than ours. It actually, no, it mathematically literally was. You know, someday I'm going to forget that joke. All right, moving on. One Earth revolution takes 365 days, which is equal to 1 year. Now, here's something else I want you to reflect on. Here's a fact. The Earth is rotating, please write this down, on its axis at the same time it's revolving around the sun. Please copy this down. I'll repeat it again. The Earth is rotating on its axis at the same time it's revolving around the sun. Yeah. Why does it seem out of focus?
I just don't know if you can read that.
I don't know either.
I zoomed it all the way back.
Well,
You want me to stand up?
if you want, I mean, you're going to get exhausted from doing that, but you're taking one for the team. Well, you might be in their way too. So you could always go over to it for like 5 seconds, and then Mr. L in the next class could just pause the video. Why don't you walk up to it right now, get a nice clear view of it for about 5 seconds, and Mr. L, if you're listening to the video along with everyone else, pause it here so that everyone can copy the board. I don't have time to edit today, so we're just going to shoot raw footage.
I'm going to go to the other side.
And then I'm going to erase it, and then we're going to move on to the next part. And you're going to keep filming, please. This part down here? Fact, the Earth is rotating on its axis at the same time it's revolving around the sun. So basically, it's doing this. It's spinning on its axis while orbiting the sun. Okay. You good? Can I erase the board? That's okay. Okay. Moving on to the next part. Let's go to SPC 1.5 seasons. So flip the page over or use a new piece of paper. We're going to go SPC 1.5 seasons. So top of your page should say SPC 1.5 seasons. All right, let's get started. Let's draw in the middle of the page a sun. Let's take the sun and let's draw the Earth orbiting the sun in 4 locations. Why do I choose 4 locations? 4 seasons. So if the Earth is orbiting the sun, how long is it taking for the Earth to move to each position? Which would be?
3 months.
So let's write in 3 months. 3 months. 3 months. 3 months. Let's make sure that our orbit around the sun is in the same direction as me for the purpose of labeling the seasons in which hemispheres. Let's take some time. Let's go to all of our models of the Earth and put them all on the same angle tilt. We're not changing the tilt. Let's go in and draw perpendicular to that our equators. And so we should have now 4 Earths looking like that, about. This is not to scale, and that is not exactly 23.5 degrees. But if we want, as a reminder, on one of these we can write 23.5 degrees, right? And let's go ahead and label each position. This could be position A, this could be position B, this could be position C, and down here can be position D. Now, on each hemisphere, let's label the hemispheres. For A is the only one that we need to write it out completely. Then we can abbreviate for the other 3. So let's write on A, northern hemisphere, southern hemisphere. And for the others, we could just write NH, SH. NH, SH, NH, SH. You're doing a really good job.
Wait, am I gonna have to like copy off?
No. I'll share this video with you, and you can use it to study. Oh yeah, in this case, you take someone's notes that you trust in class and copy them, yeah. Okay, let's make a table. Let's make the table go 1, 2, 3, 4 rows. Let's label each row A, B, C, and D. Let's split these into 2, and let's go northern hemisphere, southern hemisphere. And so what we've done is we made a table to track what season it is for the northern hemisphere and what season it is for the southern hemisphere, depending on the Earth's position around the sun. Now remember, these 4 positions, they don't just happen this position, that one, and this one, and this one. We have 3 months of time while the Earth is traveling around the sun. And you have to pardon the rudimentary fundamentals of this 2-dimensional picture showing a 3-dimension concept. The way it's mapped out, it should be a 3D model of like it going around the sun like this. So a topographic model would look different. Yep. It says northern hemisphere at the top, southern hemisphere at the bottom. All right, so let's go through here. Let's start with A. What season do we speculate it to be in the northern hemisphere for position A? If the northern hemisphere is angled at the sun, this means we're going to have more hours of sunlight, less hours of nighttime. It's going to be summertime. So let's see. A, northern hemisphere, summer. With your group for about a minute, minute and a half, I want you to fill in the rest of this chart, the rest of this table, knowing that the southern hemisphere is going to be experiencing the opposite season at the same time. So if it's summer in the northern hemisphere at point A, it must be Mr. L, at this point, can you pause the video and let everyone fill out the table? When everyone is done with the table, you can play the video and I'll go over the answers. Mr. L, thank you for letting everyone do that for 5 minutes. Let's move on to our answers. B, what season is it 3 months after summer?
Oh,
Winter.
that was Israel, by the way.
It's fall. It's the beginning of summer. It's fall.
So what season would it be in the Southern Hemisphere? Very good. Position C, we're kind of in the middle now.
It would be winter.
Winter.
And that'll be summer.
What season is it going to be for the Southern Hemisphere? Summer.
No, that's spring and fall, yeah.
And then spring and fall. Mr. L, you can pause on this right now so that everyone can see the answers and copy them down.
Is this the first lesson or the second?
This is SPC 1.5 seasons. People on Google Classroom, I want you to hand in the notes for SPC 1.4 and 1.5 on the same post. It will count as 2 assignments, but there's only one place to hand it in. Thank you.